what's up? I'm Phil. This is our final project.
I'm Peter. Okay. So our final project uses
It's got diodes, it's got capacitors, it's got op amps, it's got low pass, high pass, band pass,
and a voltage divider.
and an LED. No, it's got 3 LEDs.
Okay.
3 capacitors
So
as well. No, more than that.
Start off over here. So this is our voltage divider. The purple wire is the input, and the green wire is the output. So we can tweak this potentiometer to give this to reduce the voltage to whatever we want. So right now we're doing a 5-volt amplitude input for the purple wire, and the voltage divider changes into a 1-volt amplitude for the output for the green wire.
By the
and
way,
this yellow wire as well is also an output.
The input is an AC network sweep, by the way.
Yeah.
So over here, we're going to start off. We have a low pass filter. We've got a band pass filter, and we have a
High pass.
This is a high pass, yeah. High pass, band pass, low pass. So the whole point of this is, well, let's go through the structure of it first. We have the low pass, band pass, and high pass all getting the same input, and they all feed into their own individual op amps, corresponding with what quadrant of the circuit they're in. And then they each output into a diode, which outputs into an LED. So if we want to let's start with the low pass filter. Low pass filter is over here. We have a resistor of value
12 kiloohms.
It's a 12 kilo ohm resistor with a 0.1 microfarad capacitor going to ground. So the that resistor gets the signal, and
It also has a 3 decibel cutoff frequency of approximately 75 hertz.
yeah. So each
No,
of the
125 hertz.
125
hertz.
So
yes.
we've centered the low pass at around 100 hertz, the band pass at around 1 kilohertz, and the high pass at around 10 kilohertz. So we have a decade-based
frequency identifier.
Yes. So as we do an AC network sweep, these LEDs light up and dim according to what sort of range that they're in our we're really looking at the human hearing range. So when we sweep from 20 hertz to 20 kilohertz, we see the LEDs transition from low to band to high in a passing fashion, and in that transition point between what we would say is sort of like our transition point between our LEDs, we see the light of one give way to the next and the following.
So the cutoff frequencies for the low pass, it's around 125 hertz. So at 100 hertz is in the pass band, and then it is not in the pass band as the frequency gets higher. The cutoff frequencies for the band pass is basically just made out of a low pass filter and a high pass filter connected in series. So for the low pass filter, for the high pass filter rather, the cutoff is at around 750 hertz, and for the low pass filter, the cutoff is around 1.25 kilohertz. So the pass band is basically between 750 hertz and 1.25 kilohertz. And then for the high pass filter, the cutoff frequency is around 7.5 kilohertz. So for the band pass, 1 kilohertz is well within the pass band of 750 hertz to 1.25 kilohertz, and for the high pass, the 10 kilohertz is well within the pass band of anything higher than 7.5 kilohertz.
So let's demonstrate. So here is what.
And then after we just connect them to an op amp, which has a gain of about 5.7 for each of them.
Right.
That we can tweak that, but that's just the value that happened to work for a voltage of amplitude of approximately 1 volt that we're using, so that the LEDs light up and dim appropriately.
Right. We're working with 10 kilohertz and 47
10
kilohertz.
kiloohms and
10
47
kiloohms,
kiloohms.
10 kiloohms and 47 kiloohms, which
for a non-inverting amplifier gives us a gain of 1 plus 47 over 10, which is about 5.7. Yeah, and then we pass them through a diode before the LED just to have a little voltage drop so the transition is smoother. It's not entirely necessary, but because the LED is itself a diode, but we decided to keep them in because it works nicely. So to demonstrate, I'll turn the network sweep on, and the network sweep is right now going from 50 hertz to 20 kilohertz, just because we would want to go from 20 hertz, but it just gets really slow for the low frequencies, and this will illustrate it well. So once I turn it on, the low pass filter will turn on, then the band pass filter, then the high pass, and then it will repeat.
Yeah, you actually see the lower frequency. The lower frequencies you can actually see with your eye on the lower band pass.
Only really low frequency.
Yeah, only the really low frequencies.
Which we're not really using because we're starting at 50 hertz, which is pretty hard for a human eye to see.
Yeah, rather than, I mean, for our purposes, we were starting with 20 hertz for the band pass for the start of the sweep, but just for demonstration purposes, because the sweep takes a long time. If we started at 20, we're just starting at 50.
Yeah, so this is what happens to the LEDs as we transition. And I can show on the computer, right now we're scoping the band pass, the amplified band pass output, which, I guess I'll do it like this, which looks like this. So we start off with a low gain, and then once we get into the pass band of the band pass filter, we have a higher gain, and then go back to a lower gain. And you can see this corresponds to the band pass LED, which is right here. It's off right now, and then in the pass band,
right,
the LED turns on.
So
and
when
then
we
it turns back off. This is the high pass.
So the band pass is made up of a low pass filter and a high pass filter, and we can actually calculate the center frequency of the band pass filter by taking the square root of the multiplied center frequencies of the low pass and the high pass. Well, not the center frequencies. The
three decibel cutoff frequencies are around 750 hertz and 1.25 kilohertz, and
when you
right in between that is 1 kilohertz. So that's approximately where it's going to be the maximum frequency or the maximum gain, just because it's right in between the 3 decibel cutoff frequencies for a low pass and a high pass. No, you really can't. But yeah, so okay, and so that's how the circuit works, and then we have a few graphs just to show a few images. So this is the so starting with the low pass, this is the low pass without the op amp, with no gain, so with no active components. So we start at a 0 gain and then go down from there as the frequency increases. This is the passive band pass, which is the same thing except the gain is just lower. And this is the passive high pass, and then we have a combined picture of all of those here. This is the passive low pass, band pass, and high pass, and the band pass has a little bit lower gain than the other ones, but that's just because it goes through 2 filters, so it doesn't quite get up to like 0, which is maximum gain through the 2 filters. And this is just showing the gain of each of the op amps. Whatever. This is just showing the gain of both of all the op amps, which is about 5.7. It looks like about 6 here, just because the input is a 0.25 amplitude sine wave for the yellow, and the output's about like a 1.5 amplitude sine wave. So it's about a gain of like 6 or 5.7. And then we can combine those to have active components. This is the active low pass, the active high pass, and the active band pass filters, and then we can look at a combined picture of that here. So the max gain is around 10, which is enough for the LEDs to light up.
We actually calculated that our LEDs, because they're LEDs can have a range of different voltage activation points or activation voltages, and ours work at around 1.9 volts. So the gain that would have to pass through from a 1 volt amplitude input, the gain would have to be around, what did we say,
1.9, which is about 5.5 logarithmically.
Well, 5.5 decibels. Well, 5.5 decibels, 5. Yes. I think we said 5.7.
Yeah,
right?
about 5.7 decimals, but 10, which these all go above, like about 10, these all go above 5.7.
Right, so we actually see that around here, right around where 5.7 is, that's where our transition point is that we calculated.
Yeah.
So we try to make sure that there's a tiny bit of overlap, but when you tweak the potentiometer, the goal of tweaking it is really one of the goals of it is to actually minimize that transition point. So as you minimize, it lowers the as you tweak the potentiometer, it actually changes the transition points.
It changes the amplitude of the input wave, which changes the transition points by either making the LEDs all light up for a longer amount of time or for a shorter amount of time.
The overlap of the LEDs.
Which affects the overlap. But because of the frequencies that we chose, the overlap is pretty uniform from the low pass to the band pass and the band pass to the high pass. So yeah, this is just a nice little circuit that we made that transitions from one LED to another LED to the third LED by using the low pass, band pass, and high pass filters, and also uses diodes, op amps for gain, and a voltage divider. Okay, thank you.